All right, so we're going to work through the review of the content of the stuff that you need to know for your 9.4 to 10.1 test. One thing to note is, I said it, but you do need a calculator to do this. You can either be graphing or it can be scientific, but you definitely need one or the other. There are 2 questions that are calculator based. When we get to that content, I'll highlight which ones they are. The other thing is I will allow you 5 minutes tomorrow to fill in what you can of a unit circle so that you can use that on Wednesday for your test. It's just basically to help you out time-wise. That's all it is. Okay, so I would probably say this time the angles are a little bit more helpful. I would try to fill out as many unit circle angles as you can, and then at least maybe 1 quadrant worth of the points. The cosine, the sine, and the tangent. That'll help you when you're getting into the conversion part of this. So 9.4 was the first section that was on, or that's going to be on this test, and it is the parametric equations. So it started with graphing parametric equations. You had things like x equals 2t plus 3 and y equals t squared, something like that, where you had 2 equations. And then you would set up a t chart. This time you've got a t, you've got an x, you've got a y. And so you would plug in t's from the range that I will provide you with. So let's say it's -2 is less than or equal to t, which is less than or equal to 1. You'll plug in -2, -1, 0, 1. You're going to plug them into the x, you're going to plug them into the y, and then you're going to get your coordinate points as a combination of the x and the y. I will give you that chart because it will make it easier for me to grade. Okay, but you'll want to make sure you plug in those points. And then you'll graph your equation. So I don't know what this looks like, but let's just say it looks like this, okay? These are endpoints because there's a start and a stop with my range. And then I want to point my arrows away from the smallest t and towards the largest t. So let's say my arrows went in this direction. I would say that's the most common mistake made with parametric, is the forgetting of the endpoints and the forgetting of the arrows. Make sure that it has those, because remember, parametric is something that's done over time. Questions on the process there? Okay, the next one is eliminating the parameter. So here you're going to start out with an x equals and a y equals. They'll both have a t in it. Let's just say we use the same ones. You will solve one of the equations for one of the variables. So let's say I would, or solve it for t, sorry, not for one of the variables. Solve it for t, I would get x minus 3 over 2 equals t. And then I would take that and plug it into the second equation. And what should happen at the end is you get a rectangular equation. There's no t in it. You've eliminated the parameter, and the parameter is t. So with no t, you've taken that equation and made it rectangular. Oh, that should be squared. Squared. If it was something like that, I probably wouldn't have you graph that one. But let's say you had like y equals 2x squared, something like that. Okay, and I also asked you to graph it. This is where it's the different kind of graph from your first one. In this would just be a parabola, a narrow parabola with a vertex at 0, 0, okay? You would need to know what the graph looks like. It will either probably be a line or a parabola, something like that, okay? And this time there's not arrows along your curve. There's arrows on the ends because we don't know where it starts and stops. So when we eliminate the parameter, we are doing an approximation of what your graph looks like, not an exact graph of the parametric. Questions on that type of question? Okay, and then the last one is working in the reverse. In this one, you're going to get given, and there's 2 words, 1 there. You're going to find the parametric equation given 1 parametric and 1 rectangular. So let's say it says x equals 2t plus 3. Again, we'll just use the same one. But then let's say it says y equals 2x. One of the equations will already have the t, the other will not. And so you will take the one that does have the t, which is this one, Solve it for the variable if it's not already. This time it is already solved. If it wasn't, I would solve it for x. And then substitute into the other equation in place of that variable. So I'd get y equals 2 times 2t plus 3, and you get 4t plus 6 equals y. So the result of this question is an x equals and a y equals that both have t. So you are working in reverse this time to actually create the parametric equations. You'll get at the beginning one parametric and one rectangular, and you'll solve the parametric for that variable, plug it back into the other one, making two parametric equations, one x equals and one y equals. Questions on 9.4? Okay, then came 9.5, which was the polar coordinates. This is our introduction to just plotting the polar coordinates and then converting from rectangular to polar and polar to rectangular. So when you're, God bless you, when you're graphing, you had stuff like r theta, where r was positive and theta is positive. So if I had a positive r and a positive theta, then I'm going to move counterclockwise. And then plot my point in the direction of that theta. So if it was 2, let's say 2 pi over 3, I'm going to go around to 2 pi over 3, which is along this angle. And then I'm going to go to the second ring and plot a point. If the r is positive but theta is negative, like negative 2 pi over 3, this time you move clockwise. So I would start at 0 and go to negative 2 pi over 3, which is actually that line, and then still work my way out to the second ring to plot my point. And then the third kind is if there's a negative r. Well, I guess you have a negative r and a negative theta, but a negative r. And for these, you would move counterclockwise just like you did at the beginning, but instead of working towards that angle, you work in the opposite direction. So if I had negative 2 and 2 pi over 3, I would go to 2 pi over 3, which is here, but instead of working up that line, I work in the opposite direction on the opposite ray. So a negative r, you move away from the angle. You want to be prepared for any of those. And again, even a negative angle and a negative r, you could see you'd move clockwise, but then you'd move away from it. Questions so far? Okay, to find additional points, this was the second thing that we did in that section. If you have two options, one is keep the r the same, and then take theta and add or subtract even multiples of pi. Most of the time we used plus and minus 2 pi. The other option is to change the sign on r, making it negative, and then add odd multiples of pi. And for those, most of the time, we used plus and minus pi. Pay attention to the range on the question for that one. It will either say, give me this many points between 0 and 2 pi, or it will give me this many points between negative 2 pi and positive 2 pi. It will give you the range, okay? So you just got to pay attention to it. If it says or equal to, obviously 0 and 2 pi would work. If it didn't say or equal to, you cannot include those. So if I said give me, find, plot the point, give me 2 additional ones between this range and this range, make sure that you're paying attention to the range because it could change. Questions so far? Okay, then came the conversion, and there was 2 types, polar to rectangular and rectangular to polar. So for polar to rectangular, it started with r theta, and I need to find xy. X equals r times the cosine of theta, and y equals r times the sine of theta. Hopefully that makes sense. Remember, cosine is your x and sine is your y. So you will see this type of question either on the non-calculator portion of your test, which means it's going to be a unit circle-based angle. Something like 2 and then 3 pi over 4. And so you would do 2 times the cosine at 3 pi over 4, 2 times the sine at 3 pi over 4, and you'd know at 3 pi over 4 your cosine is negative root 2 over 2, and your sine is positive root 2 over 2. So I'd get negative root 2 comma root 2. And you'll give your answer like that. So you'll say xy equals, actually I put equals instead of, xy equals negative root 2 comma root 2. So if I'm going from polar to rectangular, then my answer is going to show that I'm in rectangular. Questions so far? All right, I'm going to come back to show you how to use the calculator for both of them. But that's the first one. That's if it's not calculator based. And then we did rectangular to polar. So for these, you start out with xy. And the first thing you're going to find is theta, the tangent of theta, equals y over x. And r squared equals x squared plus y squared. So if I gave you the coordinate point of, let's say, negative 2, 3. Oh, actually, no, let me give you one that's on your unit circle first. Let's say negative 2, 2. Then I would say the tangent of theta equals 2 over negative 2, which is negative 1. Now, at that point, there is 2 answers to every single one of these tangents. Without a calculator, you're only going to get 5 options. You're going to get 0. You're going to get your over 6 answer, which is root 3 over 3. You're going to get your over 4 answer, which is 1. Your over 3 tangent, which is root 3. Or your over 2, which is undefined. So the value will be one of those 5, but the signs obviously can be different. So I can have a positive tangent or a negative tangent. In this case, I've got a negative tangent, and tangent is negative in 2 quadrants. It's negative in my second quadrant, and it's negative in my fourth quadrant, where one's a positive, one's a negative, right? So if I want to figure out, I know it's an over 4, which means my options are either 3 pi over 4 or 7 pi over 4. If I want to know which one to pick, what do I look at? Good. The original location of your point. So if my point is negative 2, 2, I'm moving left and up, which means my theta is what? Good. 3 pi over 4. And then I just plug in for r squared. So r squared equals the square root of, or the square of -2 plus the square of 2. 4 plus 4, which is 8. If r squared is 8, then r equals the square root of 8, or 2 root 2. On my answer, I will identify that it's polar by doing r theta equals 2 root 2, comma 3 pi over 4. Questions on either of the conversions? So again, that would be without my calculator because those are unit circle base angles. If they were not, which you will, you'll get 2 questions with your calculator. One is converting from polar to rectangular, and one is, what did I just say? Polar to rectangular. The other one is rectangular to polar. So if I'm going from polar to rectangular, let's say that my equation or the question is 3, and then it's 3 pi over 5. You could see it like that, or you could say it as 3 and 1.88, okay? Those are both the same things, okay? Realize that it doesn't have to have a pi in it to be in radians. You want to make sure your calculator is in polar and radians. You don't need it to be in parametric. You don't need to switch back and forth. You just keep it in polar and radians. And so you have 2 options here. With a scientific calculator or a graphing one, I could take that process that we just did, which is r cosine theta, r sine theta, and I could type it in as 3 cosine of 3 pi over 5, and then 3 sine 3 pi over 5. And I could let the calculator do the work. Obviously, you have to do that in separate steps. But 3 cosine 3 pi over 5 would be negative 0.927. Let's say I'm just going to round to 2 decimal places. It will tell you. And then 3 sine 3 pi divided by 5. Oops. And I get 2.85. So that process can be done either graphing calculator or scientific calculator. With a graphing calculator, you also have the added bonus that it is smarter than your scientific ones.
Is it okay if it's a little off? Because I got negative 2.88.
Did you type it in as 3 pi over 5 or 1.88?
Oh, wait, I did not know.
Oh, yeah, it's a minus. Yeah, because it should be exact if you type it in that way. All right, so on a graphing calculator, there's actually a menu underneath the angle menu. So if you hit second, apps, and you get to your angle menu, on the very bottom there, the 4 bottom spots are a way to convert from one to the other. So think about what you're in right now. This question is going from what to what? Polar to rectangular. So I'm going to do them both twice, whichever one it is, because one is polar to rectangular x and one is polar to rectangular y. So I go down to polar rectangular x, I hit enter, and then I'm going to type in my polar, which is 3, comma, the comma's above the 7, 3 pi over 5. I'm going to hit enter, and it's going to give me the x coordinate for my rectangular. And then I'm going to repeat that process again, second, apps. This time I'm going to P to R, Y. So polar to rectangular, Y. Type in the same thing, 3, comma, 3 pi divided by 5. And I get 2.85. So with a graphic calculator, you could just do it that way. You could also do it both ways and check, okay? With a scientific calculator, you're only going to get to do it the first way. Questions on that one? Okay, so then the second question that you're going to get that is calculator based is rectangular to polar. but it won't be a point on your unit circle, a tangent that's on your unit circle. So let's say it's negative 2, 3. When I go to find tangent of theta, and I put 3 over negative 2, I get negative 1.5. On our unit circle, we don't know any tangents that are negative 1.5. So I would have to use the calculator. And again, you have two options. If you use scientific, it's actually kind of wrong, but I'll show you what it means. If I do the tangent negative 1 of negative 3 pi over 2.
3 pi over 2 or just 2?
I'm sorry, negative 3 over 2. I get theta equals negative 0.98. And then I would do r squared equals x squared. And I get square root 13, and my directions are going to say round to the nearest blank. I'm going to say be consistent with what we already did to the nearest hundredth. So I would actually figure out that the square root of 13 is approximately 3.61. So if I only did it that way, then I would get my r theta equals 3.61 comma negative 0.98. So if I only had a scientific calculator, that's what my answer would be. With a graphing calculator, I'm going to go back to that menu, second, apps, go down to, this time I'm going rectangular to polar, and again, there's two parts. The first part is radius, the second part is theta. So I'm going to go R to PR, and I'm going to type my coordinate point in, negative 2, comma 3, and I get that my R is 3.61, which matches what we got from the first thing. And then I'm going to repeat that process, second, apps, I'm going to go R to P theta, type it in again, negative 2, comma 3, and I get that theta equals 2.16. With me so far? All right, that does not match what I got, right? Think about why this is happening. So this time I'm saying R theta is actually 3.61, comma 2.16. Which one of those do you think is right? Which one? Which calculator one? The first one was the if we only use scientific. The second one was if we actually use the menu that what P.
The graphing calculator.
Why? Remember when we do tangent of theta, there's always two answers, right? Yes. And you have to plot the point to figure out which one it is. Yes. So if I went negative 2, 3, where should my angle be? Second quadrant. Okay. These are in radians, so it's a little bit harder to figure out. But remember, this goes way back. This is when we were talking about radians at the very beginning of the introduction of radians. We said that the radian, 2 pi, is really 2 times 6.18. So all the way around was 2 times 3.14, which is 6.28. And we said pi was 3.14. So when we were estimating whole number radians, we said that that top quadrant, the top two quadrants would be divided by 3. So maybe like this is 3, maybe like this is 2, and this is 1. And then if we continued it on to the other side, they look sort of like this, 4, 5, 6. So if I said 2.16, I would know it's in this quadrant. And if I said negative 0.98, that's kind of like negative 1, I'd know it's in this quadrant. So technically, this answer's right. But without a graphing calculator, you won't know it. So for the test, I'm actually going to take both answers. Because if you use a scientific calculator, you're going to get it wrong and you won't know it. Okay? just realize that this is technically the right answer. If you use your graphing calculator, it is smart enough to know that when we type this in, that we're saying -2, 3 is the point, which means I should be in the second quadrant, and it knows to pick the correct angle. Your scientific calculator will not know that. Does that make sense? So I, for the test, will take either answer, but realize that that is actually, the first one is actually a wrong answer.
My calculator is giving me the first answer.
These 2 questions at the bottom, those are your calculator-based questions. You're going to start with those 2 questions, and then you're going to move into the rest of your test. Questions on 9.5. Okay, so then 9.6 was all those graphs, right? The first thing you're going to do is figure out what of the 4 different kinds of graphs it is, and then depending on the type of graph, you got to give more information. So you're going to get an equation, okay? If it's a limison, you're going to go even more narrow, and tell me what kind of limison it is. So you'll know it's a limison if you get R equals A plus or minus B cosine theta, or R equals A plus or minus B sine theta. So a limison has something added to or subtracted from your function. So your first step is, okay, it's a limison. Then if it is a limison, you have 4 different kinds of limison that you then have to figure out what they are, okay? So the first one was your inner loop, and that comes from your A over B. So the first thing you do is identify it's a limison, and then you're going to find A over B. And if A over B is less than 1, it's an inner loop. Which looks something like that. Oh, but it should be a little bit lower. It should be on the axis. Let's see if I can get it better. Something like that, okay? If A over B is equal to 1, then it's a cardioid or a heart-shaped. If it is in between 1, oh, not equal to, geez Louise. In between 1 and 2, then it is dimpled. Sort of like a lima bean. And if it is greater than or equal to 2, then it's convex, so it's got a flat side. And all of those are examples of if it was cosine. If it was sine, they'd all be flipped 90 degrees to the right or 90 degrees to the left. So the loop happens at the top or the bottom. The little cardioid, the little heart part would happen at the top or the bottom. The dimple part would happen at the top or the bottom, or the convex, the flattened side. This should be really flatter. Don't make that dimpled.
Is this like a circle?
It's a flattened circle. It's like a circle with a flat side. So step 1, identify the kind of graph it is. If it's a limison, step 2 is figure out A over B, and then classify it inner loop, cardioid, dimpled, or convex. And then from there, you will plug in points. So we'll go back to like symmetry in a little bit, but if I was to find something being symmetric to the pi over 2 line, then I would plug in all the points to the right of my pi over 2, and then I would flip it over to the left. If it was symmetric to the polar axis, which is your x-axis, then I would plug in points from 0 to pi and then flip it over the polar axis. If it was pole, then I would know anything that's happening in this first quadrant is going to flip and happen in the third quadrant, okay? But we'll go back to symmetry at the end. Questions on limicons? Okay, then comes the roses. So the roses are R equals a sine, or let me go in the same order, cosine of n theta, or R equals a sine n theta. So a rose has a number in between the trig function and the theta. A lemniscate also has a number in between there, but the lemniscate has r squared. Okay, so a rose is r to the first, and then a cosine n theta or a sine n theta. So right away you'd be able to identify that it's a rose. And then the second question is, if it's a rose, is how many petals does it have? If your n is even, actually let me start odd. If the n is odd, then it has n number of petals. If the n is even, then it has 2n number of petals. So you double it if it's even, you leave it if it's odd. Questions so far? And then the other thing you're going to get from your equation with your rose is how long A is. And A is the length of the petal. So if I had R equals 3 cosine 4 theta, that's a rose with 8 petals, and the petal length is 3. And I would say for the rose, sometimes you get lucky, and when you plug in 0, you get your petal length. And so for those, if you understood symmetry, you could really only have to plug in a couple of points. Right.
Is there a certain number you want us to know?
Honestly, no, because it depends on how well you know your symmetry and how well you know your equations. Literally, if I knew it was a rose with 4 petals and I plug in 0 and I get 3, I already know what my entire graph looks like, right? Like if I know that it's a rose, I know that it has 4, like not this one. Let's just say it is this way, right? Let's say it has 4 petals. Let's say when I plug in 0, I get 3, and 3 is my A. I already know that my graph looks exactly like this. So for me, I would probably plug in the quadrant angles to confirm that what I got was right, but then that's enough. So it's going to kind of depend on your graph, and it's going to kind of depend on how well you know the information about your graph.
So we would only have to find those 4 points. We don't have to find them.
For a rose. Yeah. All right, then you got a lemniscate. So the lemniscates are the ones that have the r squareds. These are the only ones with r squareds. So this is r squared equals a squared cosine 2 theta, and r squared equals a squared sine 2 theta. So don't confuse these with your roses because they do have something attached to the theta. They are the only ones that have an r squared. And your lemniscates are your infinity symbols. So they look like either this, oh, that's not a good one. Or they're vertical and they look like this. Or they are in the first quadrant, third quadrant, or second quadrant, fourth quadrant, anything like that. Because r is squared, these are always symmetric to the pole. But that doesn't mean that's all they are symmetric to. They could be, like in this case, they could be symmetric to the pole, to the polar axis, and to the pi over 2 line. So again, I'll go back to symmetry at the bottom, but just realize they can have more than one types of symmetry. The other piece of information that you're going to get from your lemniscate is again the length of the petal. We'll call it a petal. It's not really a petal, but we'll call it a petal. The length of the curve. The difference this time is you have to square root whatever's in that equation because your standard equation is a squared. So if I had r squared equals 16 sine 2 theta, then I know it's a lemniscate and I know that a is 4. So this is another time where you might get super lucky. If I know that I know it's a lemniscate and I plug in 0 and I get 0 is 4, then I know the rest of my graph looks like that. I obviously would always plug in more than one point to make sure. But sometimes you get that lucky. Questions on that one? Okay, and then the last one was the circle, which actually was the first one we started with. This is r equals a cosine theta, or r equals a sine theta. This is also just r equals a, because if the sine or whatever is 0, it could just be a number. So if you had r equals 3, that's a circle. If you had r equals 3 sine of theta, that's a circle. And if you had r equals 3 cosine of theta, that's also a circle. If it's just numeric, then it means my center's at 0, 0, and I'm going 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3, and making a circle. If r equals sine of theta, then it means that I'm going, God bless you, from the pole out 1, 2, 3, and it would be here. And if r equals cosine theta, it'd be 1, 2, 3, and it'd be here, okay? But I'd know it from plugging in points. So the A is the distance from the pole to furthest point. When there's a trig function in your answer, that's also the diameter. When there's not a trig function in your answer, that's your radius. So your diameter would be double it. And again, when in doubt, plot your points. All right, so let's talk symmetry. So the test for symmetry, like your general test, there are 3 different types of symmetry. Theta equals pi over 2, polar axis, which is like your x-axis, and pole, which is like your origin. For the pi over 2 line, you would replace r theta with negative r and negative theta. And if your answer goes back to the original or everything is the exact opposite, then it's symmetric to the pi over 2 line, or the y-axis. For the polar axis, you're replacing r theta with r negative theta. So it would be symmetric, like if you fold it like a hamburger, top to bottom. And the pole would be r theta would get replaced with negative r theta. So that's why a lemniscate is always to the pole, because you're squaring r. So if you plug in a negative, it will always go back positive. So that's your by the book test for any different kind. But remember that there's a quick test for just the pi over 2 in the polar axis, and if it's an r equals. So if this is an r equals and sine is involved in some way, then it's symmetric to your pi over 2 line. If it's an r equals and cosine is involved in it, then it's symmetric to your polar axis. So the r squareds don't work the same way, and there's no quick test for pole. Questions so far? So if I know that it's a specific kind of graph, and then I know that it's symmetric to the pi over 2 line, then I'm going to plug in the values that are between, well, the first and the fourth quadrant. So for me, I would do 0, I would do pi over 4, I would do pi over 2, and then I would do 7 pi over 4, and 3 pi over 2. I would plug in all those points, and then I would flip them over the y-axis or the pi over 2 line to get the left side of my graph. If it was symmetric to the polar axis, then I'm going to plug in the points from the top of my graph. 0, pi over 4, pi over 2, 3 pi over 4, and pi, and then I'm going to flip them and mirror them underneath my axis. And if that's not enough information, I plug in my additional points. I plug in my over 3s or my over 6s until I figure out what that graph looks like. So there's lots of opportunity for the practice of the graphs. On your review, there's practices. On your extra review, there's practice. If you go back to what we talked about last week, I gave you like 6 different graphs for last week. There's lots of practice. All right, and then 10.1 was where we finished. So 10.1 was graphing 3-dimensional points. So if I had something like 2, -3, 4, you want to identify where your variables are. Wherever they are, that's the positive side of your graph. So if I want to move forward 2, I'd be here. I want to move left 3. I'm going to go parallel to the y-axis. 1, 2, 3. I'm like here. Up 4. 1, 2, 3, 4. You're going to actually give me your little scoop marks so that I know where you intended your point to go. You'll also see this in words. So like 2 units forward, 3 units left, 4 units up or above the axis. And you'll have to give it to me in coordinate points. So you had ones like that in your homework too. The distance formula, you already know the x and y part. We just added on the z. So this is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So you're just adding on another coordinate. Same for midpoint. x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. Well, that's off. And then the spheres was the last thing. So just x minus h squared plus y minus k squared plus z minus j squared equals r squared. And the last question we saw where you had, I gave you like the center and the radius, or you had to complete the square, or I gave you like the endpoints of the diameter, you had to find the midpoint and the radius to do it. Your reviews on Canvas, I obviously made, it's non-graded because the answers are all there. My advice is to make sure you have it done tomorrow so we can answer questions, and then also make sure you're prepared for that like 5-minute unit circle tomorrow.